Okay, so today we're going to do part two. We're going to find the area between two curves. So in this problem, I'm asked to find the area between that parabola and that line. So first of all, I got to make a little sketch. That's a parabola plus 2. So plus 2 and going upward. I'm also given the line y equal negative x. Well, I could do that one here. Diagonal line. And then I'm given x equals 0, which is a vertical line. And I'm also given x equal 1, which is another vertical line. X equal 1 is here. X equal 0 is here. So I'm asked to find the area between those two curves and those two vertical lines. So I am asked to find this area right here. And so when I look at this, I need to decide which function's on top, which one's in the bottom. So I could tell this function is the one that's on top. And I will remind you that the top function is the parabola. And I could tell that this function's in the bottom. And the one that's in the bottom is y equal negative x. So the area is the integral from 0 to 1. You can look at the graph, 0 to 1. The top function minus the bottom function with respect to x. So this is the top, this is the bottom. My limits are 0 to 1. Now, I will probably not show you every step. I distributed that, made that plus. At this time, we should all be experts at integrating. And we should all be able to do top minus bottom. You can pause the video and do the work, and you should all get 17 over 6. Right? Sometimes you're not given or you don't know the limits. If you're asked to find the area of that parabola and that line, I already graphed it, here it is. I'm asked to find this area right here. The problem is I don't know what those limits are. I don't know from where, call that A, to where this region is bounded. And I could figure out what those limits are by figuring out when these two equations are equal to each other. So I'm going to set them equal to each other. That equal to that. I'll move everything over to one side, and what we're going to have here is a little bit of algebra, because this should be a nice easy quadratic x plus 2x minus 1. And when I factor it, I could figure out that these two functions are equal at negative 2 and at 1. So the limits are going to be from negative 2 to 1. And I could tell that the function that's on top is the parabola. The function that's in the bottom is the line. So when I set up my integral, the limit will be negative 2 to 1. The top function we said was the parabola. The bottom function was the x. So again, at this point, we should all be experts. I'm not going to show you every step. I will integrate. I will integrate. I will integrate. and I'll ask you to pause the video, top minus bottom. We should get the area to be 9/2. All right, let's try another one. Number 4. Number 4, I'm given the equations g of y equals 3 minus y squared and f of y plus 1. First thing you should notice, these are in terms of y. So as soon as I see that in terms of y, I'm going to be dealing with right minus the left. I have to be in terms of y. I am given this parabola. Yeah, that's a parabola. And I'm given that line. So I'm going to say this is the right. And this is the left. And everywhere I go, this is the right to the left. The right to the left. The right graph is the parabola. The left graph is the line. So only thing I need to worry about is where are they intersecting? What is that limit and what is that limit? I need to know these limits. And I could figure out those limits by setting them equal to each other and then solving for the y. So again, I suggest you pause the video, do a little bit of algebra, find out when they are equal to each other. So I could tell that they're going to be equal when y is -2 and when y is +1. And these are going to give me the limits of my integral. The area of those two go from -2 to 1. The right is the parabola. The left is the line, and I am in terms of y. I have a dy. Now on this one, I will do one step for you because I want to make sure that we all distribute in the minus. I guess I can combine like terms. And we could all integrate. Again, pause, do the work. Should get 9/2. I'm going to keep going. One more. Find the area of the region. I am only looking at the first quadrant, bounded below by that radical and above by that line. Well, I am not given a graph here, so I'm going to make a little sketch. And when I make a little sketch here, I have a parabola. Oh, let me see. Let me do a little bit of number crunching here. I have a radical. I think I said parabola. I have a radical. So the radical looks like this. 1, 2, 3, 4, add 2. So it does something like that. And I have the line x minus 2. I'm going to kind of cheat here. That's -2. So it does something like this. So now, what region am I looking for? In the first quadrant, below that curve and above that line. So I think I'm only going to find this area right here. And when I'm going to find this area, I am not going to do top minus bottom. that top function can go down to the x-axis. But here I have a top function going down to that curve or that line. So I don't want to do top bottom and then top bottom. Why don't we go right to the left? And everywhere along this region, this is always the right and that is always the left. So I'm going to be in terms of y, right minus left. But in order to do that, I need to figure out that function in terms of y. And the g of x function, where'd it go? In terms of y. So I'll be dealing in terms of y. The right side is the line, the left side is the parabola. So area equal the right minus the left in terms of y. And I need to figure out my limits. Remember, I'm in terms of y. So this goes from 0 to 2. Remember, I could always set these equal to each other and find out when they're equal. So I could figure out that top limit. That's the setup. We could all integrate. I'll let you do that yourself. The answer should be 10 over 3. I want to do one more because the next one's going to get a bit interesting. Sometimes the curves intersect at more than 2 points. I have a cubic and I have a quadratic, and I already graphed them for you. The cubic is this one right here. This is f of x. And if you follow the curve, it has a cubic shape. The quadratic, the g of x, is this one. And what I need to be careful with is that in this first section, this first region, the f is the one that's on top and the g is in the bottom. But in this section over here, the one that's on top is the g function. The one in the bottom is the f function. So I need to set up two different integrals. This one, f minus g. This one, the g minus the f. So I need to figure out the limit here. I guess that's going to be 0. And the limit here. So I'm going to put these two equal to each other. And then I'm going to do a little bit of work. Again, I recommend you pause. It's going to be algebra. Find out where they intersect. Zero, 2, and negative 2. So that gives me the limits are going to be from negative 2 to 0, f minus g, and from 0 to 2, the g minus the f. So I'm going to set this up, my area. The first section from negative 2 to 0, the function that is on top was the f function. The function that was in the bottom is the g function. And I'm going to add the integral from 0 to 2. No, not that one. From 0 to 2, the function that was on top was the g function. the function that was in the bottom was the f. So I'm going to make sure I'm okay with that. G minus the f. So I'm going to have the g minus the f. I need to subtract the functions and then integrate. I need to subtract these functions and then integrate. And to make my life a little bit easier, why don't we use a calculator? Pause, enter the f function into y1, enter the g function into y2. Look at that, I already did it. So when I integrate math 9, I'm going to go from 0 to 2. Go to y1 minus y2 with respect to x. And I'm going to add math 9. I'm going to add the integral from 0 to 2. And I just saw a mistake. I got to fix it right now. I know. The limits are not from 0 to 2. The first one should be from negative 2 to 0. y1 minus y2. Move over here. So the second section is from 0 to 2. And remember that they switch. So I'm going to go y2 minus y1 with respect to x. And so the area will be 24. So you should be able to find the area integrating that by hand and yes, with a calculator. As a matter of fact, on the homework, 15, 17, 21, 23, 29, those you can do by hand. These you're going to use with a calculator. Okay? Let me know if you have any questions.